the vectorial relationship ui will be the eij of x. Okay, this is the vectorial relationship of displacement. This is the vectorial relationship of displacement, that is ui equals to eij xj. So ui, as I have already told you, the u is the displacement of the elastic solid, I is the sorry, in the coordinate axis of the x. Okay, in the coordinate related to the coordinate point, that is x. So we can easily write down that as previously we have written that the displacement in any direction of the matrix, that is in terms of in terms of vector, we have written that. Am I audible? Am I audible?
Yes, sir.
Okay. So there is some network issues. That's the problem is here. So in the last class, what we have derived the equation of the vector represent the vector tensor. So S I dash is equal to A I J S J. A I J S J. That is the last formula we have derived. The last formula that we have derived in that format. So related to this, if there is some displacement in terms of stress here, there is the vector that in last class we have derived in terms of vector. Here, this is vector displacement S1 dash. Here this is the displacement in the elastic solid. EUI, we can represent this EUI is equal to EIJ XJ. Simply as we have derived this in the last class. So now we can expand this equation. As we know, there are two suffix. I is the j is the dummy suffix here, and I is the free suffix here. So by using I and j, so summation will be taken over the j. Though there are the two suffixes, and j is the dummy suffix, and the summation will taken over the dummy suffixes. So we'll expand this equation. Summation will take close over j is equal to, if you take j is equal to, if we put here the j equals to if you write down here j equals to our 1 2 and 3, j is equal to our 1 2 3. Okay, so by putting j is equal to 1 2 3, and we have to go for the summation of the summation and expanding this equation, this particular equation we are going to expanding this particular equation. That means we have u1 if we are writing u1 means I equals to 1, we are putting the u1. The equation will be in the format of e1j e1j xj e1j xj. That is the format. And if we put j is equal to 1 2 3, j is equal to 1 2 3, then simply we can write e11 x1 plus, I'm going to write there just similarly I am writing e12, I'm just summation over the j, e12 xj plus e13, sorry x2 no, so writing here x2, j is equal to 2, e13 x3. This is one explanation in terms of you when we are putting I is equal to 1. Similarly, when we put I is equal to 3, that means we are writing u2. We are writing this u2. Here we are writing, we are going to write here u is equal to 2. So when we are writing u is equal to 2, that means we are putting here, sorry, it is u is equal to 2. When u is equal to 2, the equation will be e2j xj. Similarly, and we can expand it now, e21 x1 plus e22 x2 now plus e23 x3. Okay, Similarly, you can expand the U3 also. I am writing this equation first here. Okay. U3 will go to the U3 here. U3 U3 means summation over E3J xj. So equation will be like that: E31 x1 plus E32 x2 plus E33 x3. Okay. So this will be the explanation. If the equation, the stress equations or the displacement equations is given in that format, so equation can be write in this way. So explanation will be written in this way. So here, when we are talking about the displacements, when we are talking about the deformations, that means it is the strengths. That means these are the strengths. These are the strengths. So let's move to this slide. So I think you will clear here you how to expand these equations, how to expand the displacement equations. S1 dash is equal to Aij. In the same manner, we are writing the displacement Ui is equal to Eij and Xj. And here these are the strain components. Most of the all of the components are the strain components, and these strain components and the coefficient from this equation, the coefficients are from this equation, the coefficients of this equation are strain tensors. Coefficients of this equation, are strain tensors. Okay. From in this equation, the coefficients are the strain tensors. Remember this: the strain tensors. These are the strain tensors. So what is the equation is going to be? Suppose we are taking two matrices. Going to take two matrices. How to what is the format of writing the matrices? We are going to write. Take these two matrices here. See this. One matrix is A, and other matrix is B. If we are going for the product of these two vectors, we are taking two vectors. So A is the one vector, and B is the other vector. A has the component of A1, A2, and A3, and similarly B has the components of B1, B2, and B3. If you go for the multiplication of these two vectors, that means we are multiplying A and B. Vector multiplication A and B. What will be the vector multiplication? The result will be, what will be the result of the vector multiplication? Just writing here. Vector multiplication of A and B. So what is the format of writing this vector multiplication? That all the quantities are multiplied: A1, B1, A1, B2, A1, B3. This is the first case, sorry, B3. Similarly, this A2, B1, A3, B1. This is A2, B2, A3, B3, A3, B2, and this is A3 and B3. Okay, so this is the vector quantity what we have got in by multiplying two vectors. If you are replacing these terms, if we are going to replacing these terms, this vector multiplication term, I am going to replacing this vector multiplication term, in which I will replacing this. See here, we are going to have to replace these vector terms. See here. How to replace this vector terms? So I am taking a second rank tensor. The multiplication, see this. What is the number of components here? If I am multiplying two vectors, What is the number of components here? This is 1, 2, and 3, 4, 5, and 6, 7, 8, and 9. 9 components. The 9 components means it is a second rank tensor. It is going to be a second rank tensor. The multiplication of two vectors having 3 components each will be a second rank tensor. Will be a second rank tensor. So though it is a second rank tensor, so it will be very easy for us to represent the same format for the stress, for our stress also, because we know the stress is a second rank tensor. We know that it is stress is also second rank tensor. It is a second is the case of a second rank tensor because it has 9 components. Though it has 9 components, it will be second rank tensor. In the similar format, if you try to replace these equations in the stress tensor format, how can we write this? The question is, how can we represent these equations in the second rank tensor? If I am writing this second rank, I am writing here for the second rank tensor. Okay, Tij. I'm writing this Tij. In place of AB, I'm writing Tij. And in place of A1, B1, I'm putting Tij means T11, T12, and T13. Similarly, T21, T22, T23, T31, 32, T33. We can represent this in that format. Is it understandable or not? Have you got that? How to represent TIAB to TIJ? Is there any difficulty? You can ask here. Is there any difficulty to understanding these equations? You can ask me here. Okay. Let's see here. We are now representing the multiplication of two vectors AB. In terms of AB, we are writing Tij. That T11 in place of I, we are writing 1 and j is equal to 1. Sum over the j. J is equal to 1, 2, 3. The summation over the j, that is j is equal to 1, 2, 3. This is the best format to best format for the writing the stress tensors. So if there is any transformations, transformations means any displacement, a transformation of the axes, the vector components. In the last case, in the last class, what we have discussed, the S1 and the S1 dash. S1 and dash is the transformation vector. Similarly, if you're going to calculate here the transformation of the components, vector components, that means the transformation means if you the in vector A, the transformation will be A1, A2, A3. The transformation, if you are talking about the transformations now, we are writing this. If we have the transformations, so you are writing A1 dash, A2 dash, and A3 dash. The transformation, these are the transformations. Similarly, we have B1 dash, B2 dash, and B3 dash. We have the transformations. We have the transformations here. So for the transformations, we have if there is a normal equation that with the multiplication is a1 b1 a2 b2, and that will be the normal equation without any transformations. If there is any transformations, then what will be the relationship between the 9 components of this second hand matrix? How to define the relationship between this first derived, this is the first derived 9 components. These are the first derived 9 components. And if there is any transformations occurs, then how we can relate these 9 components? How can we relate these 9 components? And these 9 components, these 9 components can be written in the format of, what will be that we are writing that there is the transformation. Transformations means what we will write the in case of that transformation, we will going to write here that is like we are writing Tij. For transformation, we can write here T dash Ij. T dash Ij. T dash Ij. After the transformation, see, after T dash Ij means the relationship of 9 components after transformation of axes. Relationship of 9 components after the transformation. After the transformation. After the transformation of axis. After the transformation of axes. That is T dash Ij. So how can we relate that T dash Ij? If you are writing T dash Ij means, or otherwise we can say this A dash B dash also. T dash Ij means, otherwise we can say this A dash B dash also. If in that format we are writing A dash B dash, that we can we are using the Ij already. The two suffixes we are already uses. So what is the method of writing the suffixes? The best method. What is the best method to writing these suffixes after this, after the transformation? So see here how we're going to write this. So we are writing one is A, one A I dash, and other we are writing here is B Ij. Already we are writing Ij, so here we cannot using again Ij. That we are all pre-suffix. Pre-suffix will be changed here. One pre-suffix is for A, another pre-suffix is for B vector. So I is for the A vector we are using, and K for we are using for the B vector. So the method of writing how we are representing this transformation. The transformation is similar what we have written in the previous equations also. The transformation equation what says that Aij, that is Aij, and the main equation that is Aj, the main vector that is Aj. This is the same format. The equation which we have derived in the last class is the most important equation in the tensor terms. So this is the equation. This is the derivation of what we have derived in the last class. This equation. So that is applicable to all the equations. That is long terms. All the complicated equations of the transformation of the stress tensors. Stress. The tensor is the method of easiest writing of any complicated equations. So is there any issue? Someone has that message here. Preeti sir. I don't know. Galaxy S70 Preeti sir. So join in your name. We can change. You can change your name there also. By rename also. By renaming yourself in the Zoom, you can join by your name. Otherwise, you will log in at the Zoom and your name will be shown to me. Okay. So. So how can you write then now? How can you write that B dash K? Similarly, we can write here in the first. What we have writing here in the method of writing, the first is the pre suffix. So you write the K here first, then the dummy suffix the J, then BJ. Okay, BJ. Oh, sorry, that we are not using that BJ because it is already used in equations, above equations. So we are using here KL. So Ij is used in the above equation. So we are using here the L, KL, BL. Okay. No. Now this equation looks all right or not? So we are going to be find out the relationship and the multiplication vector. So we are now find out the a dash a dash a dash I into sorry b dash. What we have here V dash k. You are writing here the equations. So what will be the equation? It looks like that: Aij Aj into, so just writing here. AKL into BL. This is the equation now comes. This is the equation now comes. So in terms of, we can write that in terms of T tensor component, we can, if you want to represent this, then we can write T dash IK. Here the component is IK. We are writing in terms of tensor component T dash IK. So now T dash IK is equal to what? AIJ, AIJ, AKL, AJ and BL. This is the equation. This is the equation now. I think you can understand this equation. There is no issue. If you go step by step, there is no issue. There is very simple equations. And these are the very simple equations. Okay, just a vector multiplications. We are just transferring this equation, transforming this equation. So, in terms of AJBL, we are not writing AJ. Yes, A and B. We are not writing A and B. So, we can replace this AB with the T also. We can replacing this A and B with T also. Okay. So how can we write in terms of T? That will be T JL, TJL, TJ and L. Since the stress is a second rank tensor, the component of stress tensor can be written. As you know, the stress is a second rank tensor. So these components are written in the same format, the 9 component format. The stresses are already written in the 9 component format. So we are going to write the stress components. The stress component, how can we write the stress component? Sigma ij. We are writing sigma ij. Stress is a 9. Stress is a second rank tensor. So the method of writing the stress is here. Now from the vector, we are focusing to the stress, how to writing the stresses. So this is one of the most equation. Okay, to the equation, that is, you can represent this as one equation one, the transformation equation. This is the transformation equation. Okay. So what is the method of writing the sigma 1? If you are writing the sigma ij, so our method is sigma 1 1, sigma 1 2, sigma 1 3, then sigma 2 1, sigma 2 2, sigma 2 3, sigma 3 1, sigma 3 2, and sigma 3 3. Okay. So now we can replace these equations also. See here. See here. Carefully what I have written here. See this. The sigma 1 1 can be written as sigma x or sigma xx. We can say this sigma xx also. Sigma 1 2 is the tau xy, and sigma 1 3 is the tau xz. Okay. Now sigma 2 1 is the tau y x, that is sigma yy, or we can say sigma y, sigma 2 2, and sigma 2 3 is the tau y z. Similarly, this is tau zx, tau zy, and sigma zz or sigma z. So this is the method of writing the stress tensor equations, sigma ij format. So like in the case of the above case of the transformation in the vectors, so we can write the transformation equations for the sigma or the stress also. Like the case of the above equations, like the cases of the above equations, these above equations, the transformations, Ti, T dash Ik. Similarly, you can go for the transformation of the tensor sigma dash sigma ij from x1 x2 x3 from system of axes to the x1 dash x2 dash and x3 dash. If the main, what is the main aim of saying that this is sigma sigma 1 sigma 1 2 sigma 1 3, that means we have the axes x1 x2 and x3. If there is a transformation in the axes, that means if axes are transformed to x1 dash, x2 dash, and x3 dash. So how can you write this? Now how can you write these equations? In the same format, what is the format written over here? In the same format, we can write the stress tensors, stress transformations. The stress transform, what is the equation written here? So we can written like that here. I'll going to here. The upper part will be better for you understanding this. I'm going in writing in upper part of this equation, the same line. Okay. Okay. If you are writing the transformation of the stresses, so what is the format of writing the transformation of stresses? So and the equation can be written here like the same format, in the same format, sigma lk, sigma lk is equal to, what is the sigma lk or kl? We're writing that kl. Okay, kl j k then l na, alphabetical, that is kl, kl sigma, sorry, kl sigma kl, sigma kl is equal to, what is writing here? First a k, then another a, that is l. Okay, then sigma the first I, that is ij, the first transformation equation, the first equation ij. So what is writing here? We are writing here I, the method of writing, the how we can write these equations. Okay, see this I, then here j. Have you understand? Have you got that equation? Have you got that equation? How to write the stress tensor equations, transformation equations? If you are writing here any term you can write, then forget about the stress and stresses and all other things. If I am writing a is equal to akl here, akl or ab, sorry, xy, I am writing axy. So how can we write here? So I am writing here, the method of writing this tensor equations is that, for example, I am giving you some examples here. Axy. So axy means we are writing there are other another terms also there. If we are writing the transformations, na, so you are writing a x, then there is a y. Okay, then there is the previous component of this previous component is, if that is small xy, I am writing this small xy previous component. So that means here we can write xy is confusing, xy is confusing, so that is I am using it here a x inverse xy mn.